everyone. We are from the group Testbed. I'm Brynard.
I'm Brydon.
Hi guys, my name is Satish.
And I'm Wen Jun.
Okay, now we are going to present our academic poster with the title Autonomous Vehicle Problem and Testing Solutions. Okay. When Henry Ford made cheap, reliable car, people say, "Nah, what's wrong with the horse?" That was the huge bet he made, and it worked. Think about it. The evolutions of automobile industry has been developing rapidly. From horse, we create a steam engine car. Then, automobile industry evolved to gas-fueled car, which we use currently. In a later time, autonomous vehicle definitely and surely will replace our transportation method. However, there is a concern with how safe is the autonomous vehicle is. As you can tell, we basically entrust our life with the decision of machines. It will surely cause controversy among us. So, it is a great obstacle if humans want to implement it on a daily basis. Now, my friend Brandon will describe the problem of the autonomous vehicle.
Okay, so I'm Brydon. This problem mentioned leads us to the question that we have to ask: is autonomous vehicle safe? Currently, I can say that no, it is not safe because autonomous vehicles are not fully tested and regulated yet, but it will be in the near future, hopefully. And so basically, the problem started because there have been multiple incidents that occurred throughout the development of autonomous vehicles. The incidents that occur can affect the lives of the driver, passengers, and even possible bystanders, such as the pedestrians. Hence, the safety of autonomous vehicles require more comprehensive testing before it can ensure that no lives are lost during the automated driving process. So in 2018, an autonomous vehicle under Uber, the company Uber, had caused a fatal accident when a pedestrian was crossing the road. So the human driver was supposed to act as a safety mechanism, but the safety mechanism did not work properly because of the lack of attention from the human driver. So in the end, the vehicle hit the pedestrian crossing the road with the bike. And there are different viewpoints whether this incident was due to human error or technological error. So the co-founder of Drive.ai has said that autonomous vehicles follow the rules too well and are unable to expect human behaviors when humans break the rules. So this leads us to the question, who is at fault? Was Uber at fault, or was it the pedestrian, or perhaps the fault of technology itself, which leads to many speculations about the future of autonomous vehicles. So I think that's about it for the problem. Next, I'll pass the solution to my teammate.
So hello, my name is Satish, and now I'll be resuming on the solution-wise. So the first solution that we came up with is the black box assessment method. There are two types of assessment approach which we use: is the path planning approach as well as the adaptive importance sampling approach. So for the path planning approach, it's an approach used to search for an autonomous vehicle system route adaptation failures by designing disturbance trajectories that investigate the overall environment. This means that an autonomous vehicle will be placed in an disturbance trajectory is, for example, a random tree algorithm. So autonomous vehicle will be placed in a random area with different disturbance, and we have to test the adaptation failures of the autonomous vehicle system based on the results obtained. So the commonly used method is the rapid exploring random tree algorithm. Whereas for the adaptive importance samplings approach, we have to use algorithms to test the reliability of the autonomous vehicle. The method used to identify and rank the failure scenario to test the autonomous vehicle in a black box to accelerate the rare event probability. We use the sampling distribution, which is the Q bracket X, that presumably produces failures and used to estimate the probability of failure with a limited number of samples. So So this is an overall overview of the black box assessment method. Now let's have a look at our second solution, which is the average mileage. So the method we're going to use to conduct average mileage is to demonstrate the reliability in terms of fatalities and injuries experienced by the autonomous vehicle after it has driven for a certain mileage. As you can see, based on the analysis of what we have obtained from the web, the data of average and fatal accidents will be compared to human-driven vehicles to determine the feasibility of autonomous vehicle rather than human-driven in terms of low rate accidents. So as you can see in the graph, we need to have a minimum of 5 billion miles to demonstrate the confidence level of the autonomous vehicle failure rate compared to the human driver failure rate. As you can see here, 5 billion miles is needed to demonstrate with 95% confidence level that autonomous vehicles failure rate is lower than the human driver failure rate. For the results wise, we can see that we can obtain valid information using statistics shown in the analysis and the likelihood of the autonomous vehicle experiencing any sorts of failure after a long journey, no matter if it's a failure in terms of the vehicle itself or the system itself. So using this study, we can further revise the shortcomings of autonomous vehicle and the upcoming automobile industries. So this is a basic approach and the overview of the average mileage solution that we've come up with. So now I'll pass on to my teammate for further explanation of the third solution.
I'm Wen Jun, and I'm going to explain about the third solution, which is divide and conquer. And what is divide and conquer? It's all about we dividing the car into 4 categories, which is first, decision making, second, human-machine interface, third, vehicle control, and fourth, perception. So what is about the decision making? It is about testing the ability of machine to do the right decision, such as the path planning, changing the lane to left or right. And moving to the second category, which is human-machine interface, is testing about the interface between human and machine. And what is it about? It can be the screen, it can be a voice recognition, and we need to test, is it precise and is it convenient to use for the human-machine interface. And moving to the third category, which is vehicle control. It's about testing on the ability of machine to control the braking system of the car, to control the steering system of the car, and also the acceleration of the car. In this testing, we're going to test the ability of the machine to control the system fast, because we want the machine to brake the car in a short time. And moving to the fourth, which is perception, we're going to test the sensor of the machine. Well, the sensor of the machine is like receptor of our humans. It's our eyes, our ears, our nose. So for the machine to have a good sensor, it can pass a correct and precise data for the machine to process, to produce a correct decision for the vehicle to move. And about how we test the 4 categories, we're going to test it in 5 phases, which is first, software in loop, second, vehicle in loop, and third, physical verification phase, fourth, physical validation, and fifth, physical in loop. So that's it for my divide and conquer solution. I'm going to pass it to Brynard to explain about the next solution.
Okay, so I'm going to present the last solution to test the autonomous vehicle, which is fleet learning. Fleet learning is a method that will run over and over again. First, the machines will record and learn the driver driving behavior. Now it will collect all the driving data when a human is operating on it. Now, at the same time, the machines will make a decision making from background based on the data from the sensor. Now we have 2 data, right, which is human driving behavior and the machine's decisions. So these 2 data will then be compared. If there is differences between them, it means that the machine did not fully achieve how a human drive a car. How should a human drive a car? So the researcher will twerk and twerk and twerk until it satisfies the researcher. And this simulation will run over and over again with different scenario. For example, the first scenario may be in a icy road. The second scenario may be in a rocky road, and so on. So as long as this process will keep repeating, the precision of the machines will get nearer to the human behavior. I think that's all for fleet learning. I will pass it to Tai Wen Jun to conclude our academic poster.
Well, after explaining the problem of the autonomous vehicle, I believe we have give you insight and build awareness about how dangerous and how important is the safety of autonomous vehicle. And after explaining about the 4 solutions, and I believe you had gained knowledge and know how to test on autonomous vehicle. So we must test the autonomous vehicle, because if we don't test it, we are allowing a machine, an untested machine, to run a 1-ton metal in the road, and it will 100% put danger of pedestrian, driver, co-driver into a serious danger. So the government, the authority, and other party, they have to put their attention to the testing of autonomous vehicle, so we can have a safe drive to our road. Thank you. That's all from us.